Hi guys, I'm Matyáš Racek and welcome to another video about the judging system. This time I will be talking about normalization. Last time we had a bit different, a little bit more abstract topics, which are important, but this time I thought it would be nice to go into some more concrete things, just so we can have a bit diverse content. And one thing people usually don't understand very well is the normalization process in the judging system. And because I will be talking about this a lot, and I will be talking a lot about the processing, these scores, I think it would be nice to just go through the system, how it works, so we all are on the same page and all understand how it works under the hood. So if you don't know anything about the system, all you need to know for now is that judges give you points for your tricks, and they will give you points by using these clickers. They will give you positive points when you land tricks, and they will give you negative points on the other hand when you miss the tricks. And then we get all those scores, we put them in the spreadsheet, and this spreadsheet will somehow magically crunch the numbers and we will get the results. So that's usually how people understand it. And today I want to show you that it's not really all that much magic, it's just simple addition and multiplication. And I guess you would come up with something like this if you had a similar problem to solve. So, what is the problem? To show you how it works, I have some raw scores from one little Czech contest, and I got a permission from judges so that I can show you how the system works on these. So here we have players. Here are positive clicks from all the judges, and here are negative clicks from those. Let's see this. I will graph those scores so you can actually see what is the problem and why do we need the normalization. So if you think about it, if we had some kind of this problem, we would just get the scores and we would make an average of those scores and it would be it. But let's see why we can't make an average. And it is because all judges click differently. Some judges click more, some click less. Some click string hits, some click elements, and it's often you will see in the scores that some judges will be clicking maybe 2 or 3 times more than some other judges. It's not really all that rare. It happens usually on big contests where there are a lot of judges from different parts of the world. They will be clicking very differently. So here, those are all Czech judges, but you can already see the difference. Like the yellow judge here, he's clicking more than the other ones, the other 2 guys. So if we made an average out of those scores, his scores would brought every score a bit up, and basically he would contribute to the final score more. His scores would have a bigger impact, and we want every judge to contribute the same way. So that's one problem that the judging system is trying to solve. And the other problem is that clicks are not bound by anything. Basically, you can click as much as you can, but we have also evaluation scores, and those are bound. Those have maximum. Clicks don't have maximum. But we want to have some kind of stable ratio between the click part, between the technical score and the performance score, the evaluation scores, if you will. So we need to somehow come up with a method how to combine those scores so this ratio is always the same. And those are 2 problems that the system is trying to solve. And the way it does, I will show you right now. So the first thing is pretty simple. It will just subtract the negative scores from the positive. So let's do that. Here. I will take Vašek's positive score and subtract Vašek's negative score. And I will do this for all his scores and all of the judges. So right now we have subtracted scores. I will graph it out again. And here you can see that we still have the same problem. The scores are not, they are a bit closer because we subtracted minuses, but they are still not not on the same level where we could actually process them in a similar way. So right now comes the normalization part, and basically what the system is doing now is basically doing two steps at once. Basically, we try to do the thing with the maximum score, and we also try to bring all the judges between different values. So what the system does at this point, I will show you. Just take vašich clicks, and so you can see. So here I can explain it better. So basically, if I take a maximum out of those values and divide every score by this maximum, what I will get? Well, I will get a number that will be always between 0 or 1. Let's see, I will show you how it works. So I will count a maximum out of those scores, which is 72, that's Michal Malik, what a surprise. And right now, I will divide every score in the list by the maximum. So what happens is that for a maximum score I will get 1. You will see that. So let's see the list right now, and look what happened. All those values are between 0 and 1, and if we do this for every judge, all those scores will be between 0 and 1. So basically they would had a maximum, consistent maximum, that we will be sure that they are at most 1, and they will be on the similar level, so we can compare the judges between themselves. And you can see that here I divide Malik scores by the maximum, which is 1, and all the other scores are lower. The result will be small number divided by the bigger number, which is smaller than 1. Here you can see, for example, the first score is 34, which is roughly, it's a little bit less than the half of 72. So here I get almost like 0.5, it's 0.47, which is like a half. So let's go back to the list and do this for all the judges. We will take this score and we will divide it by maximum out of all of the scores from the same judge. And what we need to do again is to freeze it on the same range. And we will do this for all scores from the judge. Those are the same as on the previous slide. And we will do this for all the judges. We can see, and right now you can already see something interesting. All the judges have the maximum here. They have 1 here, which is Michal Malik's score. What a surprise again. But one judge, the middle one, he actually has a maximum also on another player. So what we need to do now is that we need to bring this to the correct ratio that we want in the final score. Usually in the system we use now, it is 60. So all we need to do is just multiply this number, multiply the normalized score by 60. Do this for all the numbers, all the scores, and for all the judges. And hey, now you can see that the maximum is 60 for each judge, and all we need to do to compute the final score is to just take an average out of all 3 scores for each player. If you don't know what is average, Google it. You should know this from elementary school. And you can see that the average from the maximum scores for the maximum players is again 60. So this is one interesting insight, what often people will tell you, that if all the judges agreed on the maximum, you will get maximum 60 points. So that's, from the final score, you can't really tell too much about the individual scores. But one thing that you can tell is if the judges agreed. So if there is a 60, then the judges agreed on who is the winner in tech score, of course. So what I will do right now is that I will graph those out again, so you can see that they are on similar level, and what you can see what the normalization actually achieves, which is interesting because right now, let's see this. Right now you can actually see one of the problems with this approach that I will be talking about in future videos. Let's see the original scores. Here are only the positive clicks here, and here you can see that the yellow judge is higher than all the others, but we normalized it, and the reason why we did the normalization was to bring the scores together. But you can see that for red judge, we actually kinda didn't do it. All of his scores are now higher, and maybe you can see why this happens. You can post a comment or something, but I will be discussing this a lot more. So basically that's everything I wanted to say for today. One thing is that I want to say is don't bash the judges. This is not really about judging about individual judges. This is just to show you how the system works, and these guys were so kind to allow me to show their scores. So, you know, don't be picky on them, please. That's all for today, so thank you for listening, and I hope this all made sense and now you understand the system a little bit better and you are prepared to discuss it more deeply in next videos, and maybe you can already see some problems with it and maybe you can come up with some solutions. The thing is, this method is not the only method to solve the same problem, and right now it's not actually clear why do we use this method and we don't use some other method. So part of what I'm trying here is to try to come up with a method that will be well justified, that will make sense in our case. For example, instead of average, we could use median. Like, why not? Why do we use average? Why don't we do something else? And we can't really answer this question unless we specify the goal. So if you watch the last video, you can go to see the document, and from the goal we will derive what do we actually want and what the system should be like, and from there it will be easier to actually come up with a method that makes sense for our purpose. So thank you a lot again, and see you next time.